Okay, we're going to go through. Not working. Touching home. No, that's not what I want. Anyways, we're going to go through. Oh, that's the one I want. Yes, dividing rational expressions. Okay. So we have a question here. A rational expression is where you have division as part of the question. Okay. So as we can see, we have some polynomial. It's just like an equation, think of it as. It's an equation divided by an equation. And then we actually are taking that, so think of this as a single term, and that's being divided by another two equations or one polynomial, depends how you define it, divided by another. So lots of division going on in this question. What we need to do is we're going to have to set up what our restrictions are, and we're going to have to organize this so we can actually carry this out, because think of these as essentially fractions. You could think of this as, do this in red, this is going to be part A, okay? So we could say that is the letter A. This part is B, so it is now divided by the letter B. And that is all divided by, get our highlighter out, C, and we'll call this D, and we'll give them letters on our other page here. So we'll say, oops, C divided by the letter D. Okay. The reason we do that is because it's actually going to help us, because we're going to work with one part of the equation at a time. So I might work with A to do a little expansion or distribution. So if I say we're doing A, just kind of keep that idea in mind. Okay. So let's shrink that. Put it over there for now. Make it straight again. Okay. So we need to. Do we want to set up our restrictions? Actually, this isn't a really good setup. This question to set up our restrictions. A restriction is that we can't have the division or the divisor, so your denominator can't be equal to 0 in any of these cases. Okay. So what we have here is you kind of have. Let's say we're talking about D to start off. The letter D here, we'll call D, and I'll do it in black. D is equal to, x plus y squared. Okay, with that being said, D can't be 0. The reason being is we can't divide something by 0 because it's considered undefined. Okay, so it doesn't matter what our value is on top, we'll say x. We just can't divide by 0, otherwise we get an undefined expression. So what we're going to do, oh, it's all part of it now. Forget it. We can get rid of it. We need to find out what the bottom part of this, how this could technically become a 0. So we can do, well, it's already factored, which is really nicely for us. As long as x and y aren't 0, then we're going to be okay. Let's pause this. Okay, so what's neat about this is this one has actually two different variables. So we're going to take this expression, thank you, and we're going to say x plus y squared cannot equal 0. That's going to be one of our restrictions. So that's the letter D there. Well, in the same concept, we can actually decompose this. Think of this as x plus y times x plus y. Right? Technically, we combine the two of them to make it squared. I'm just going to decompose it a little so it's a little simpler for us. It cannot be 0. Well, they're both the exact same expression, so we don't actually need that squared. What we can say is just x plus y cannot equal 0. Well, we don't need brackets. X plus y cannot equal 0. Shrink this a little. There we go. And if I bring y to the other side, it's going to say x cannot equal, well, negative y. And same thing, y cannot equal negative x. So I know it's not an actual value, but one of our restrictions is they can't be the same value and one the negative version of the other, okay? Because if you add them together, they're going to create a 0. On the other side of our equation, we technically have, let's talk about b for restriction. So I'm going to say the letter b over here. B is equal to x squared minus y squared. Okay, this is actually a difference of squares. So I'm going to factor this one. When we go to factor it, we're going to get x minus y, x plus y. Do you remember a difference of squares? Does that factoring make sense? Okay, So we have a difference of squares, and our restriction says that they just cannot equal 0. So we're going to split both of them, because this one, they're actually technically different equations. 0 cannot equal x minus y, and 0 cannot equal x plus y. Okay? So, two different questions. We can drop the brackets from both. 0 cannot equal x minus y. 0 cannot equal x plus y. And in this case, x cannot equal positive y, and x can also not equal negative y. Wonderful, because we've already established that one restriction over here, x can't equal negative y. That one's done for us. This is our second or our other new restriction, so I'm going to highlight it in yellow. So here's one of our restrictions. Here's our other major one. Now, normally that would be it when you're dealing with rational expressions. You take one denominator, the other denominator, state the restrictions, and you're good to go. Well, because this is a division question, we're actually going to have to invert this and then state the restrictions from the numerator on the second one. So actually, let's see if I can shrink this one more time. Yay. Okay, and then we'll move it to the other page. So we're running out of room. The reason we're going to do this, I'm going to move this question over here a little, is we're going to change this division into a multiplication question, because we don't tend to divide fractions. We usually say invert and multiply. So I'll rewrite it again. We have x minus 2y squared over x squared minus y squared. And then we're going to invert this, and we're going to change it to a multiplication question. So multiplied by, and we're going to invert this, x plus y squared. That lags, doesn't it? That's fine. And then on the bottom we have x minus y squared, x plus 3y. Okay, great. So we got to do our, what letter do we call it? C. We're going to have to state the restrictions for C here. So that's our last set of restrictions we got to state. C is equal to x minus 2y and x plus 3y. Okay, same idea. These two things cannot equal 0. X minus 2y, x plus 3y. And again, the reason being is because it's now a denominator. Okay, so let's split this equation again. We're going to get 0 cannot equal x minus 2y, and 0 cannot equal x plus 3y. So we're going to get two new restrictions. I'll move x to the other side. It becomes negative x cannot equal negative 2y. Can you see that? And over here we'll get negative x cannot equal positive 3y. Well, we don't normally write restrictions as negative x. We write them as a positive value. So because it's negative here, we're going to just multiply both sides of the equation by negative 1, or divide by negative 1. It's technically the exact same thing. I'll just write it up here. We'll say multiply by negative 1, multiply by negative 1. Same idea here. And what we're going to end up with is x cannot equal 2y, and x cannot equal 3y. So we now have another set of restrictions. So this is a very in-depth question. We have 1, 2, oh thanks, 3 over here, and 4. We have 4 major restrictions. I'm going to state them down here. Then we'll actually get into simplifying this question. So our major restrictions are, number 1, x cannot equal negative y. Number 2, so that's this one here. Number 2, x cannot equal y. Number 3, I checked that one off. Number 3 was x cannot equal 2y. Check that one off. And number 4, x cannot equal 3y. Check that one off. Okay, we literally just did a whole bunch of work just on restrictions. I'm going to have to remember this when I make the next page. Okay, well, what are these values here? On this page, are a part of it, we wrote them in the bottom corner. X, negative y, positive y, and y2 and y3. So I think it's still working. Sorry. X minus 2y, x square. No, x minus y, x plus y. Okay, multiplied by, on top we have x plus y squared over x minus 2y, x plus 3y. Okay. These squares, they essentially mean we can rewrite those brackets the exact same. If it makes it simpler for us, we can. It's completely up to you. Because this is multiplication, there's a rule in multiplication that it actually doesn't matter what order you multiply things in. And because it's fractions, you're always going to multiply the numerator by the numerator, so these two, and the denominator by the denominator. So I'm actually going to turn this into one very large fraction right now, okay? And in fact, I'll rewrite these so that they're no longer squareds, but we'll rewrite the bracket twice. So we have x minus 2y, x minus 2y, okay, so that stands for the squared. And then we have x plus y, that again stands for the squared, all divided by x minus y, x plus y. We can put them together, x minus 2y, x plus 3y. Okay, looks like one giant rational expression. All we got to do next is start eliminating brackets that are the same. So I don't know if you see any here. We have x minus 2.
X plus 1.
Perfect. So on the numerator and denominator, that's exactly what I meant. So we have 1 here, x minus 2y and x minus 2y. And you said right here, x plus y, x plus y. Any other ones? Nope, that looks like it's it. So we've eliminated those. Ooh, I got a lot of stuff there. Okay, move that over. What are we left with? Okay, so after we've simplified, on the bottom here, we're left with, geez, I can't see.
X subtract 2y.
Yeah, thank you.
And then x plus y.
Perfect. Over
X subtract
plus
y.
y, x plus 3y. Oh, that's it. Perfect. We got rid of 2 on the top, 2 on the bottom. Great. So this is our simplified version, and technically our restrictions from before kind of collate all the information. Here's our simplified version, and our restrictions: x can't equal y, x can't equal negative y, x can't equal 2y, and x cannot equal 3y. Huge question. A lot of work done.